Alright, this is an equilibrium problem involving gases. We are given initial conditions and asked to calculate what the equilibrium pressures are of each gas. Actually, we're just trying to determine the product gas. Alright, so we'll start with our ice table. Initially, we have 0.5 of hydrogen, 0.9 of nitrogen, and no ammonia. We're going to lose 3x here, lose x of the nitrogen, and gain 2x of the ammonia. So we have 0.5 minus 3x for the equilibrium, 0.9 minus x, and 2x. As always, the equilibrium concentration is the initial plus the change. So we have K sub P is going to be the pressure of ammonia. We have to square that over the pressure at equilibrium of H2 to the third and the pressure of N2 at equilibrium. Alright, we can sub in what we know. So this is 4.3 times 10 to the minus 4. This is 2x, quantity squared. And this is 0.5 minus 3x, quantity to the third. And 0.9 minus x to the first power. Now this would be a crazy problem to solve full out algebraically, so we're going to look to see whether or not we can do the simplifying assumption. Okay, we can make that if K times 1,000 is smaller than our initial concentrations. That means that we're going to have 5% or less error introduced by making that approximation. So in this case, K times 1,000 is 0.43, and that is smaller than either of our initial approximations, so our approximation is okay. So we have our K sub P, and that's going to be equal to 2x squared, or should we do the quantity here? Well, actually, let's substitute in here. This is 2x quantity squared, so we know this is going to be 4x squared. And on the denominator, this is our approximation. We're going to have 0.5 to the third and 0.9. Okay, what we've done is indicated that these two values are insignificant compared to the initial concentration. And again, note we've checked so that we know that this approximation is okay. Okay, now if we solve for x here, we would find that x is 0.00348. Now that we have x, we go back and answer the question. The question is, what is the partial pressure of ammonia at equilibrium? So the pressure of ammonia at equilibrium is equal to 2x. So that's 2 times 0.0348, and we get our final answer of 0.00696 atmosphere. 0.00696